So here we go, guys. Balancing chemical equations. We did this in class, but apparently we need a video. Okay, here we go. So, step one, be sure to have a skeletal equation with correct chemical formulas. This is really important to make sure that you have correct chemical formulas, because without them, you will not be able to balance equations effectively, and you'll get very, very frustrated. So, we see that manganese metal and hydrochloric acid solution react to form manganese 2 chloride solution and hydrogen gas. So we have to make sure that we have a good skeletal equation with good formulas. Okay, step two. Step two, draw a T table. I call it the RNP table. So you can see here we've drawn a T table. Step three, we're counting. Or now actually, on step three, we're not counting yet. On step three, we're listing the elements. So you can see how I listed the elements over here. So I have elements listed right here. Here are my elements listed right there. Okay, so that's step three. List your elements, list your substances that you have. Okay, step four, count. I want to count how many are on the reactant side and how many are on the product side. So you can see that I've done that. Next, step five. Now I'm going to use coefficients. I'm going to only use multiplication because I can't add or subtract. I can't change chemical formulas. I can only change the front. I can only add coefficients, and so that means multiplication. So I go through and I look. I have 1 and 1. Down here, I have 1 and 2, so I multiplied this side by 2. When I did that, that 2 that I used right there went right up here. It also changes the Cl because it's with the HCl. I cannot put it in between the HCl. This is the formula for hydrochloric acid. I can't change that. So then I come down here and I also change the Cl. And so I get that. Now I have 2 and 2, that's good. 1 and 1, that's good. 2 and 2, that's good. So you can see how we go through the process. Notice they do not all have to be the same number. So you see the Mn is not 2. It does not have to be 2. The only thing that has to be 2 are the things that need to be 2. So Mn is equal on both sides, H is equal on both sides, Cl is equal on both sides, and here are the coefficients that balance that equation. Okay? If it's not mentioned, what is it? Yeah, it's 1. So that's where the 1s come from, guys. Okay, so now you're balanced. There it is, 5 steps. Pretty easy steps. You have to take your time with that last step. You have to look at what you've got and you have to figure it out. But you can't do that without having correct formulas first. All right, so some tricks. Tricks of balancing 1. When balancing elements that appear in 2 or more places on a single side, separate them. So what do I mean by that? This is what I mean by that. Okay, so you can see right here, I've separated them. Okay, so I have an O here and I have 2 O's here. So I separated them 2 plus 1 so that I can remember that I have things in multiple places. That's what I want to know. I want to be able to remember that. If I don't remember that, then I change things and I don't get things right and I'm really confused and I'm really frustrated when I get there. Okay, so when we do that, we can see that we can balance this chemical reaction pretty easily, and there are the coefficients that balance that chemical reaction. Okay, pretty simple when we really think about it. Okay, so when you have things that are appear in 2 or more places on a single side, separate them by a plus sign. You're going to add them up, they're going to be equal to the same amount, but we separate them to make sure that we know that we have to change them a little bit. Okay, so trick two, when balancing polyatomic ions, treat them as one unit if they appear on both sides of the equation. They have to be whole and they can't be separated anywhere else in the equation. So what am I talking about here? Up here, I see one polyatomic ion. I see this one right here. I see PO4 there, and I also see PO4 there, and I see nothing with P or O anywhere else on the reactant side. So there's nothing else over here with P or O. So I go ahead, and when I list my elements, you notice I list PO4. I don't list P and O. You can. It works the same way, but I feel like it's more complicated, and eventually you get to the point where you do this anyway. So if you see them the same on both sides and they're not broken down on either side anymore, they've got the same thing in the same place, then you're good. So here we go. So I've counted here. There's step 3, okay, or step 4. So now I've balanced. So I've gone through and made everything equal. And notice how I didn't change the PO4s, I didn't have to. Okay? So, what are some other helpful hints? Be methodical. Don't be a tennis ball. Don't tennis ball your way through the problem. Don't go here and then go here and then go here and then go here. You'll forget something and then you won't be effective. Always begin at the top and try to never begin with balancing H or O. As a matter of fact, if you have an H or O, sometimes you skip those and come back to them. So if they're in the middle, they're not at the bottom, skip them and come back to them if you can. Sometimes you don't have to, but if it seems complicated, do that. In combustion reactions, the coefficient of the hydrocarbon must be doubled to make O work out sometimes. So when you have a combustion reaction and you notice you have an odd number of O's on the product side, you're going to have to double your hydrocarbon. So that means you have to double everything that you've done in order to figure out what to do. So double the hydrocarbon, double all your other numbers, and then come and solve for the O when you're finished. Okay, so that's pretty much it. Simple, quick, and down to the point.